Welcome friends. Let us study about the engineering scale on my YouTube channel. Kindly like and share this video and subscribe my YouTube channel. In today's lecture, we are going to study about the introduction, representative factor or scale factor and unit conversion for metric system and unit conversion for British system. Introduction. Student, can we draw map of India on a real paper or a notebook or a drawing sheet or a sketchbook in actual dimension? What do you think? No, right. Then how objects having large or small dimensions are required to be drawn? So if you want to draw our map of motherland India, or if we want to draw the ant or coronavirus, then how we can draw it? Yes, we have to take the scale. So if we take the scale, then we can draw the same thing. And what are the example of that scale? 1 kilometer of actual distance can be drawn as a 1 millimeter on drawing. Or the another example is 0.1 millimeter of actual distance can be drawn as a 10 centimeter on drawing. So we can take the scale like this and then we can draw the map of our motherland India or the coronavirus. So when we take the scale like this, that is a 1 kilometer of actual distance is equals to 1 millimeter of drawing, that is which is known as the 1 millimeter is equals to 1 kilometer. It means on drawing, if it is 1 millimeter, it should be considered as a 1 kilometer. And here dimensions are reduced on the drawing, and as the dimensions are reduced on the drawing, the scale is known as the reducing scale. And in this scale, 0.1 millimeter of actual distance that we can show as a 10 centimeter of drawing. So actually it is written as 10 centimeter on drawing, it is equals to 0.1 millimeter. And here the dimensions are increased, and therefore it is known as the enlarging scale. So when we take this scale, we have to require or we have to find out how much dimensions are required to be reduced or how much dimensions are required to be increased. So whenever we are going to take a scale, we should know by what you can say ratio the dimensions are to be reduced, or by what ratio dimensions are to be increased. And this change in dimension or reduce or increase, whatever it may be, this change in dimensions are defined by a ratio, and that ratio is known as the scale factor or a representative factor, RF. So the definition of RF is, it is defined as the ratio of dimension of object in drawing to actual dimension of object. It means it is a ratio of two things. One is dimension of object in drawing. So whatever the drawing we are drawing, what is the dimension of that particular object in drawing divided by what is the actual dimension of that object. Clear? And the representative factor, now what do you mean by dimension? Generally we consider length as a dimension. So the length of object in drawing divided by length of object or actual length of object. So representative factor, again length of object in drawing divided by actual length of object. So it means if the length of object in drawing is 1 meter and the actual length of the object is 1000 meter. So it is nothing but what we are representing? We are representing 1000 meter, that is 1 kilometer of actual object by only 1 meter in drawing, and therefore it is known as the reducing scale. And what is the unit of RF? Because the same unit meter cancel, so we can say it is a unit less. So RF is a unit less, and it can be written as 1 by 1000, and it is a reducing scale. And the another scales may be 1 by 1000, 1 by 10, 1 by 500, 1 by 7000. All are the examples of the reducing scale. It can also be denoted or the symbolized as 1:1000, 1:10, 1:500, 1:7000. So all these are the methods to denote the reducing scale. Now let us take the another example. Length of object in the drawing is 1000 meters. That is a 1 kilometer. And what is the actual length of object? That is 1 meter. So here 1 meter of object, actual object that we are drawing as a 1000 meter. So here it is known as the enlarging scale, and as you know, RF is a unitless. So what is the RF for the enlarging scale? 1000 by 1. What are the another examples? So it can be 10 by 1, it can be 500 by 1, it can be 7000 by 1. So all these are the examples of the enlarging scale. And again they are denoted also as 1000:1, 10:1, 500:1 or 7000:1. Now my question, if RF is 1 divided by 1 or it is 1:1, then this scale is known as, yes, this scale is known as the full size scale or a true scale. It means drawing and objects are of same size. So representative factor, again we know it is the ratio of dimension of object in drawing to actual dimension of object, and we know that generally dimensions are considered into the length, but it is not the case for all the time. So dimensions can be represented as length, or sometimes in numerical dimensions are given in area also, or sometimes in the numerical dimensions are given in volume also. So if these are the dimensions, the RF equation for different cases are different. So we have studied already about if the dimensions are given in length, then our equation of RF will be RF is equals to length of object in drawing divided by actual length of object. So this already we have studied. Now the next case, if the dimension in area is given, then the equation for the RF is under root area of object in drawing divided by actual area of object. So this is the case if in your example, if in your numerical dimensions are in area is given, then we have to find out RF using this equation. And if dimension in volume is given, so in that case we can calculate the RF using this equation, that is cube root volume of object in drawing divided by actual volume of object. So here we have studied if the dimensions are given length, that is okay. If the dimensions are given in area, we have the equation, and if the dimensions are given in volume, then we can use this equation. So that is you can say according to the numerical, according to the data given in the numerical, you are required to use the proper equation. Now the unit conversion, that is the important while you have to draw the numerical on the scales. So 1 kilometer is equals to 10 hectometers, 1 hectometer is equals to 10 decameters, 1 decameter is equals to 10 meter, 1 meter is equals to 10 decimeters, 1 decimeter is equals to 10 centimeters, 1 centimeter is equals to 10 millimeter. So you are required to study and understand this dimension. So and unit conversion, it is required for the numerical calculation. So this is the unit conversion in metric. Similarly, unit conversion in British. Sometimes in the numerical, the dimensions or units given are in British unit. So here we are also required to convert the you can say unit, and for that you are required to remember this thing. 1 mile is equals to 8 furlongs. 1 furlong is equals to 220 yards. 1 yard is equals to 3 feet. 1 foot is equals to 12 inch, and 1 inch is equals to 2.54 centimeters. So this unit conversion you are required to study and remember. Kindly ask your queries in the comment box of the video. Kindly like and share this video and subscribe my YouTube channel. Thank you.